Now that we've looked at how to calculate residuals by hand, you probably guessed that this is a lot of work to do for every single data point, and tedious work at that. So we're going to look at how to find these residuals in Excel, as well as Excel will calculate them for us. So we're going to go through both of those processes, and we're going to revisit our data set on coral reefs. So this is the data set that was concerned with how sensitive to changes in water temperature are coral reefs. To find out, scientists examined data on sea surface temperatures and coral growth per year at locations in the Red Sea. So we're going to switch over to Excel, and you're looking for the data tab that's called Coral Residuals. So there are two coral tabs, but there is one that has the word residuals on it, and that's the one you want to look for. So I'll see you over in Excel in just a second. All right, so this is what you should be looking at, or at least your setup should be fairly similar to this if you're on the correct tab. And I do have that coral reefs scatter plot with a line in it that we made earlier in this chapter. And I want to just take a quick look at this before we get to calculating the residuals. So when I look at this, I see that there are 4 data points that sit below the line. So I'm going to expect that those 4 will have negative residuals. And then I have 3 data points that sit above the line. So I'm going to expect those to have positive residuals. All right, now to calculating this, we have all of our X values here. We have our Y values. So these are our observed data. And now we need to work on the prediction. So a lot of times in statistics, if you see Y with a hat over it, it means it's a prediction value. So they use that line to predict what that value would be based on that. So to do this, we're going to use this equation of the line, negative 0.3031, and we're going to multiply it by the X value and then add 11.962. So it's going to look like this. I'll do equals negative 0.3031, and I'll use a star for the times. And I could type in this 29.68, but I want to make my life a lot easier for myself. So I'm actually just going to click on the box that has that. So that's A3. So if negative equals negative 0.3031 times A3 plus 11.692. So that'll give me a value of about 2.695, bunch more decimal places. So there's my predicted value. And then to get the residual, I'll do equals, and I'll click on the box that has the observed value. So this 2.63, and I'm going to put a subtraction sign, and then I'll click on the one with the predicted value. So I have the y-axis minus the y-hat, so it's B3 minus C3. So I have a difference of negative 0.065. So this is one that's sitting below the line. And now I could sit here and type all of these for every single data point, but the beauty of actually using the cell number like A3 or B3 instead of typing the number itself is that I can copy and paste this, and it'll automatically update those cell number locations to the next row. You can also, there's a little green square in the bottom right-hand corner. You can click and hold that down and drag it, and it will also copy all of those formulas for you correctly. So we have all of our predicted values now and all of our residuals. We have 1, 2, 3, 4 that are negative, which is what we expected, and 3 that are positive. And then the next, the sum of the residuals is 0.011. So that is not exactly 0. We did say that the residuals should add up to 0. The reason that it doesn't look like they're adding up to exactly 0 is that there's a rounding issue here. So this slope and intercept are actually have never-ending decimal. So the more decimal places you use, the better the accuracy and the closer you're going to get to actually true 0. But for all intents and purposes, this is 0.01. That is close enough to 0 to kind of really illustrate this point. All right, so that wasn't too bad for us to put that formula in there and calculate those residuals, but Excel will actually calculate the residuals for us, which is really cool. You do need those data analysis and solver packages downloaded. So if you haven't downloaded those, the directions are on Canvas. There's a link on the Chapter 5 page, and it should take you 60 seconds, 90 seconds to download those. Once you've done that though, you're gonna, instead of being on the home ribbon, you want to switch to the data ribbon. And all the way over on the right-hand side, it says data analysis and solver. So that's where those packages show up that you downloaded. We're gonna use this data analysis one. And then the name of this chapter, there's lots of options in here, but the name of the chapter is regression. We're finding regression lines. And so that's the choice you want to choose here. And one really important note, so this gets people a lot of times, that wants the y values before the x values. And traditionally, we always start with the x values and then the y values. So this is backwards from your expectations. So that's just my one word of warning. So once the y values first, and you can see that it's just blinking in this box, I can actually go over here and just highlight these. And it'll automatically pick up that range, those cells. And then I'll click on the box for the X range, and I'll do the same thing with the X values. And then down towards the bottom, you'll see a spot where it says residuals, and you're just going to click the box that actually says residuals. Then I'm going to change the output range to somewhere on this page. There's actually, it defaults to just creating a new page with the information you asked for, but I'd like to be able for us to compare it. So I'm going to change the output range to post these numbers on our page here. So put these here. And I'll say okay. And here we go. So it gives me a whole lot of information, but here are my predicted values, and here are my residuals. So that first one was negative 0.067, and this is negative 0.065. So that's where that extra accuracy makes that difference by the time you get out to about the third or fourth decimal place. So these are close enough. I would be happy with either one of these answers if you gave these to me on a homework or a quiz. This would be totally fine. But there you go. Now you can see just another way of doing it and much faster. Plus you get a lot of other great information like the mean and the standard deviation and things like that on this. Okay, and then there is one more detail we need to check, and this is part D on the notes. It says find the correlation coefficient R between the C temperature, so that would be the X values, and the residuals. So we're using X and the residuals, and it should be really close to 0. I mean, this is just a special property of how the least squares line work. So you'll notice that over in columns G and H, I have it all set up where it actually brought your residual values over that you'd already calculated, and then it has the X values. So all we need to do is go to this box where it says correlation and put equals CORREL. And then we'll highlight those X values and then the residuals. So we get 0.00027. So that is virtually 0 there. So this is another property. Anytime you're using that least squares regression line, that relationship between the X values and the residuals, there should be one. That correlation coefficient should be 0.